Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, and faculty members across India, initiated by myself in 2017. We used to organize online problem solving sessions and online test series to help the students who prepare for different national level competitive examinations regarding higher mathematics. As a part of that series, today we have Mr. Himanshu Rewri from Haryana is with us. Mr. Himanshu is now doing PhD in IIT Delhi. He did B.Sc from Shaheed Bhagat Singh College, University of Delhi, and he qualified JAM in 2017 and joined at IIT Jodhpur for doing M.Sc. And at that time, he qualified CSIR JRF, GATE examination, and joined for PhD at IIT Delhi. And his broad research area is commutative algebra. Today, Himanshu will discuss with us some selected problems from the area of real analysis. I would like to express my sincere gratitude on behalf of my Maths Aspirants groups to Himanshu for joining with us. I hope that today's session will be really helpful to all of you. I welcome everyone to this program. Welcome, Himanshu.
So, hello friends. Today session will be clearly a problem discussion session. So, I will be happy if all of you will take participate and ask question whenever you want. So you can stop in between also. And so please be participate and whatever the question is, so ask it in the between. So I have selected some questions from the JAM CSIR. So the level is not that much high. So my first and the problems are mainly based on point set topology and sequences also, not even the series we are taking in this discussion. So let's start our discussion now. So the first question is, if y is a set x divided by 1 plus mod x such that x is in R. So the question is, find the set of all limit points of y. So the options given are open interval -1 to 1, -1 to 1, where 1 is closed, close 0 to 1, and -1 to 1. So what do you think, like which option will be fine? I hope that everyone will know the definition of limit point. So is there anyone who don't know the definition of a limit point? Yes. Is there anyone who don't know the definition of a limit point? Okay, so I'm assuming that everyone knows the definition of a limit point. So how will our set look like, the set y?
Sir, x plus 1, x by 1 plus x for x greater than equal to 0 and x by 1 minus x for x less than 0.
Okay. So for x greater than 0, our set is x divided by 1 plus x, right? And for x less than 0, but it will look like
X by 1 minus x.
okay. So let's write this x, change this x variable to minus of y. Then it will look like something -1 divided by 1 plus y. Is that fine?
Yes, sir.
Yes, sir.
So for x greater than 0, this is always greater than 0 and less than 1. Is that clear to everyone? This thing?
Yes, sir.
For this also, this is less than -1 and lies between 0. So this value when x is less than 0. Is that fine?
Yes, sir. Fine.
Yes,
So
sir.
basically our set y will belong to -1, 1. So now can you tell me like what will be the set of all limit point of this set y?
The option D.
Yeah, option D. So is this clear to everyone? Is there any doubt in that D part? Yeah, question number 1.
No.
No, sir.
Sorry. Okay, fine. So let's go to the question number 2. So the question number 2, the definition of a set is similar to as that of question number 1. So first tell me how this set will look like. Say if this set is y or say this set is s. Then how s look like?
Option A.
Greater than equal to 0 but less than equal to 1.
So is this what you are saying it?
Yes, sir.
Okay. So which option will be correct then? So is this set connected?
Yes, sir.
Okay. So there is no gap between. So this is an interval. That's why this is connected. And is this compact?
No,
No, sir.
it's not closed.
Why this is not compact?
It is not closed.
Okay.
It
So
is
the
not
definition of compact in R is it should be closed and bounded. So this is and I am using it. So the set S is not closed. Why it is not closed?
1 is the limit point, but 1 does not belong to the set S.
Right. So 1 is not a limit of this set S. Sorry, 1 is the limit of this set S, but it is not in S. That's why it is not closed. Okay. So let's go to the question number 3. So read this question number 3. Let S be a closed subset of R. T is a compact subset of R. So this is a question of JAM 2016. So the question says that S is a closed subset of R. T is a compact subset of R. Such that S intersection T is non-empty. Then what can you comment about S intersection T? Can anyone answer that?
Compact.
Sorry?
Sir, its intersection T is compact.
Okay. What about others? So the one answer comes to be compact. So is there any other option available? Like who thinks that that answer is correct other than C? So given is S is closed. T is compact. So T is compact implies it is closed and
Bounded.
bounded. Then what about S intersection T?
Closed.
Closed. Since T is bounded, it is
Yes.
bounded also.
Yes, sir.
So you know that option C is for sure true. So can you give me counter example for A, B and D? So D is automatically incorrect because in option we have not compact also. Similarly with A also. So can you give me example of B? Why it is not closed?
B is
Yes,
incorrect.
and why B is incorrect? Give me a counter example if it is incorrect.
Because we have given that S is closed and T is compact, means T is closed and bounded. So not closed means intersection of S and T should closed. So B is incorrect.
Okay, so this question number 3 is done. Let's go to the question number 4. So the
Sir,
question,
I want to ask one question, that how do you say that S is bounded?
no, in question number 3, T is compact subset of R.
Yes, sir.
So it may not be true that S is bounded. S may be unbounded.
Yes, but S intersection T is, you say that S intersection T is closed and bounded, then we also
Yes,
have
because
property that,
because we are given T is a compact subset of R. So that means
yes, sir.
T is closed and bounded.
But it also means that S is also closed and bounded. When you take S intersection T is closed and bounded.
No, can anyone contradict himself? Can anyone give some example of a
Yes,
statement?
sir. I am taking S equals to natural number and T equals to closed interval 1 to 3. I mean from 1 to 3. Then
Okay.
S intersection uh, T will be finite set
Yes,
and
it is.
bounded and bounded set. So finite set is closed and bounded, so compact.
Yes, correct.
Yes, sir. Thank you, sir.
Now let's go to the question number 4. Read the question number 4. So the question number 4, that S is the set of all limit points of the set, this given set S, which is n divided by root 2 plus root 2 divided by n, where n is a natural number. So here this n is a natural number. So the question asks about whether this set S, the set of all limit points that contains Q or is contained in Q or intersection with irrational number is non-empty, and the option D is intersection with rational is non-empty. So what can you comment about this set S? So the question asks, what can you comment from the set S? And the option available are this A, B, C, and D. Yes. Okay, how our set S will look like? Yes, anyone? Increasing sequence. Okay, fine.
Pretty infinite set. So
Okay, so that will be visible to everyone that this is a countable set.
yes, sir.
So someone commented in the group that S is contained in Q. And other one commented that S intersection R minus Q is non-empty. So two answers come still now, B and C. So I have said that this set n divided by root 2 plus root 2 divided by n is countable set. So that means that B may be true. Yes.
So can you explain once more?
No, till now I haven't said anything about the answer of this question number 4. So does
No,
can
sir,
any
about the B option.
B option why? Why option B?
You said that it is countable. How?
Okay, because n is a natural number, right?
Okay, sir. So,
Yes. So for putting the values of n, we have
I think sir S is 5.
Sir, what are the limit points of this set?
Sir, you are not audible.
Hello, Himanshu.
Sir, no audible, sir.
I think some connection issues with him. Yeah,
yeah.
Himanshu, you are muted. Please
I'm
unmute
sorry.
yourself.
So
Yeah,
actually there is some connecting issue. So like
okay, no problem. You can go.
okay, so let me give you a hint of this question number 4. So try to plot this on the real line. Now tell me what do you see and what can you comment about this question? So say 0 is here. Then for n is equals to 1, we have 1 divided by root 2 plus root 2 divided by 1. So this is somewhere here. Then again put n is equals to 2. We have our set here. Again try to plot for n is equals to 3 and continue in this manner. Okay, so I am unable to read all the comments. So if possible, please try to unmute and give me a suggestion. Okay, now can you think of this? What will be the set of all limit point which is denoted by this? So I'm claiming that it will be an empty set.
Yes, sir. The set is countable
Yes.
and all the points are irrational.
All the points are
Irrational.
Yes.
okay. So then how you will claim that this limit point will be a empty set? So this is my claim. So if this is true, this thing, then this is incorrect, and this is incorrect. Then option B is correct. So now my question is why this is true.
Sir,
Sir,
if
this set is converging to infinity. I mean diverging to infinity.
Okay.
So it has no limit point.
Okay.
Sir,
So
if
is
we
that
take
statement true? Yes.
sir, if you take neighborhood of any point which is given by initial to 1, 2, 3, we can consider any neighborhood which intersection with set S is empty. So it is not limit point.
Okay. So what about others? But can you comment on this? The statement given by Mahesh?
Sir, if we take a limit point L and we take a neighborhood which where epsilon is less than half or less than one third, very small, then in that neighborhood we cannot get infinitely many points from the given set because it is the
Okay.
elements are given
Can
as
you
n
see
by.
can you see the neighborhood? Can you see the what difference it will take so that it will guarantee that the neighborhood of any point will be an empty intersection? So between these 2 points, so what will be the difference at least needed so that intersection will be an empty intersection?
Sir, if we take epsilon as less than 1 by root 2.
Yes. So see this, notice this. So whenever n is tending to infinity, this difference because of this root 2 by n, this is going to be 0. So whenever n is large, so the at least difference should be n divided by root 2. So take the difference point s in s, take s minus n divided by 2 root 2 and s plus n divided by 2 root 2. So I'm saying that if these 2 points are there, so if this is some point say s in s, then take this point, the difference of this n divided by root 2 and divided by 2 root 2 from both sides. So for this difference, for this interval, the intersection of any 2 points will be an empty intersection. So is this question number 4 clear to everyone?
Yes, sir.
Okay. So let's go to the question number 5. So the question number 5, we have the collection 1 divided by m plus 1 divided by n says that m and m comma n is in n. So m comma n are natural number. And also we are considering 0 in this set. So my question is, what can you comment about this set? This. So is it compact and open? Compact but not
It is,
open? Not compact but open, neither compact nor open.
I think B option true.
Option number B. Okay, what about others?
Yes. Because limit point 0 also belongs and 1 by n also belongs. So it is closed must.
Okay.
And of course limit point or lie between 0 and 1. So
What about
bounded.
others?
Sir, one
So
is a
this
limit
set,
point, but one is not in the set.
Sorry?
Sir, I don't think it's compact because 1 by m, these are also the limit points. Such that
Okay.
m belongs to n.
Okay, let's say the set is S. So this is clear that this is bounded. Because this set S lies between 0 and 2.
Yes, sir.
Okay. So now for compactness, what you need to show?
Closed
Closed.
and bounded.
Yes.
it is countable set.
Hmm.
So it is closed.
Okay, what can you comment about the open? The set whether S is open or not?
So this is countable set.
Sir, not
Yes.
So
open.
not open.
Countable, so this is not open. Because open interval in real line are the open sets. So any open interval is uncountable.
It is not necessary because Q is countable but it is not closed.
Sorry.
Q is countable.
Yes.
uh,
No, I'm
but
saying that
it is
the set S is not open.
S is it is closed because limit point 0 also belongs.
Yes. So S is closed. So this statement is correct. Why it is correct? Tell me. Why? What is S dash? The set of all limit points.
1 by n union 0.
Yes. So the correct option for this question number 5 is
B.
B. So
Sir,
is that fine to everyone?
sir,
One
1 by
paper.
n. Sir, 1 by n's are not in S, no.
1 by n.
Sir, the elements with the form 1 by n such that n belongs to n. They are not in S.
They are not in S. Yes. So So this another statement comes. Can anyone comment on this statement?
Sir, if we fix n and n tends to infinity, then
Yes.
it gives set of 1 by n term, which is also limit point.
Sir, take n equal to 1 by 2n and m equal to 1 by 2n, and we will have 1 by n in this address.
Yes, correct. So now is there any doubt in this question?
No, sir. Okay, sir.
So is this question number 5 clear to everyone? Any doubt in that? Okay. So let's go to the question number 6. So the question number 6 is similar to that of question number 5. So the question number 6 says that if S is the set 1 divided by 3 raised to the power n plus 1 divided by 7 raised to the power n, where n and m are natural number, then which of the following statement is true? So S is closed, S is not open, S is connected, and 0 is limit point of S.
Option D.
Option?
D must be true.
D.
Option D. Okay. What about other options? So 0 is clear, like when n and n comma m are tending to infinity, then 0 will be limit point. So when we take the neighborhood of 0, then there are infinitely many points of S, such that intersection with the neighborhood of 0 is non-empty.
Fine.
What about A, B, and C? Okay, so
C is
is
false.
this S connected? Option C.
Option C is false.
Why? Reason?
Since rational number does not belong to the set. Irrational number does not belong to this.
Anyway, the one reason is like it is a countable set. So what are the connected sets in the real numbers? These are open intervals. So is this clear why the statement C is false?
Yes, sir.
Okay. So C is false. What about A and B?
Since 0 does not belongs to S, so it is not closed.
Yes, exactly. If we remove the 0 in the previous question, the set also is not a compact set. So 0 is essential for this set has to be closed. What about B? Yes, B.
S is countable set. So S is not open.
Correct. So S
So
is not
B
open.
is true.
Yes. So in question number 6, the correct options are option B and D. So can we go to the question number 7?
Sir,
S is
my
not
question
open,
is
then S is closed now.
No. The question is about the set S is open or not. So if it is not open, that should be closed or semi-open, semi-closed.
Okay, sir.
Yes.
Sir, my doubt is someone says since S is countable, so S is not open. It is necessary to all of countable set.
See, if we are considering about the real numbers, then if your set is not uncountable, then it should not be open.
Okay, sir.
Yes.
Okay, thank you, sir.
So can we go to question number 7 now?
Yes, sir.
Okay. So the question number 7 is again based on a connectedness. So the question says like, if which of the following subsets of R is a connected set? So this question comes in JAM 2018. So the first option is X is the collection of all elements such that x square plus x is greater than 4. X square plus x is less than 4. And option C is mod x less than mod of x minus 4. Option D is mod x is greater than mod of x minus 4. So there are two ways of doing this question. So the one way is find the whole set A, B, C and D. So by defining the modulus property and using the inequality and all. And the other way is using graphical approach. So how you will do this question number 7? Yes, Shashank Joshi commented like by sign diagram, fine. Tejaswini Lockyer says that by graphical approach, this is also fine. So how you will do it?
For option A, from sign diagram, it must be gapping between two roots. Means left or right side, there is gapping between them, in which set A is not lie.
Okay.
I think it's D greater than 0, so it must have two roots.
Okay.
So since it is greater than 0, so between the roots there is gapping.
Okay.
So it is not connected.
Then what about option B?
Option B is connected, I think.
Option C and D? Yes, so someone says like by graphical approach. So that approach for me also a better approach of doing this question, because this saves at least 1 or 2 minutes for me. So can anyone suggest me like how we will do it?
Sir, for option A and B, we can consider the quadratic equation x square plus x, the graph of x square plus x minus 4. It will
Yes.
have a minimum point at x equal to minus half.
Yes.
And at x equal to minus half, it is negative. And for x tends to infinity and x tends to minus infinity, this f goes to infinity. So we can say that it will cross the x-axis at some point, and then again it has two roots. So for x option A, x square plus x greater than 4, it is not connected because it will give me two disjoint sets. But for option B, it will give me an interval, so it is connected.
Yes, I have used some similar type of approach in this question. If you see clearly that this is the general form of a parabola.
Yes, sir.
and as she said, like that we have a minimum somewhere here. So the parabola will go like that. So how I have done this question, I know that there is some point x naught such that it will lie below this line. I have taken only one point, say I put x is equals to 1, then I have 1 plus 1, 2, that is greater than 4. So definitely one should not be in the set A. So it should lie below this line. So my parabola at least intersect at 2 points. And for x going to infinity and minus infinity, my parabola will go up. So at least I have two components for this set, for this curve and for this curve. So this is how I think of like how it have two components, two connected components. So in this part A and B, the option number A is incorrect because it is not connected. Option B is correct. So this will be the open interval for the roots say alpha naught and alpha 1. So the graphical approach and by sign diagram we will get the same answer. But it may save your time like how you will do the question. Okay, what about option C and D?
I think both are correct because in C case there is a x less than 2 part which is minus infinity to 2.
Okay.
And D part it is 2 to infinity. All of things are I think connected.
Okay. So have you defined the modulus property for part C or D?
I think I square both sides.
Okay, you square both sides. Okay, so this way you also can do it.
Just a square minus b square.
Yes. Yes, what about others? Option C and D.
True, sir. But we can use the graphical method also here. Like we can draw the graph of mod x and mod x minus 4 and compare.
Yes. So this is also you can do it. So how my mod x will look like? This is mod x. What about mod of x minus 4?
Shift 4 unit forward.
Here. Is that correct?
Yes, sir.
So where it will cut now? So now see when this curve mod of x minus 4
2
is
point.
upper than the curve mod of x. So this is one way of doing this question. So the interval for first part will comes out to be minus infinity say 2, and for second it will become it comes out to be 2 to infinity. Okay, so is this question number 7 clear?
Yes.
So the correct options are option B, C, and D. Okay, so let's go to the question number 8. So this question I have taken from the CSIR, but this type of question is very common to comes in various type of exams. So that's why I considered this question. So the question says that which of the following sets of functions are uncountable? So these are the collection of all functions, and we have to comment about which of the following sets are uncountable. So option A, the collection of all the functions from natural number to points 1, 2. So is this uncountable?
Yes, sir.
Why?
Yes.
I think no. Because we can define even function goes to 1, odd function goes to 3. I mean, odd number.
Okay, so you're saying
So-
that even number are going to.
No, it is not bijective. Yes, sir, it is countable. Uncountable.
Yes.
It is not
Why?
bijective. It is many one.
Countable, uncountable. And what will be the reason for that?
So uncountable. The set is 2 to the power n, 2 to the power natural number. The count.
Yes. Why it will be 2 raised to the power cardinality of n?
Because for every natural number we have two choice, 1 or 2. For image.
Right. So in general, for any set, if we are given a function from A to B, then the number of functions from A to B is cardinality of B raised to the power cardinality of A. So this you can prove it for. This is very easy to prove. So if you know this, then this option A is correct.
Yes, sir.
So this is same as the cardinality of power set of power set of
Power set to natural number.
Okay, what about option B?
It is countable.
False.
Countable.
Why?
We can construct bijective function from 1 to 2n.
So what will be the cardinality of this set?
In natural number plus natural number.
Yes, sir.
And why it is countable?
Well, if not to the power square.
Right. So we know the result that product of finite Cartesian
Countable.
product of finite countable set is countable.
Countable.
So this is same as the this is same as saying that this is set of positive rational numbers. If you have seen the proof of positive rational number. Okay, what about this set C? The option number C?
False.
Countable.
Yeah, because this is a subset of option number B. So this is also false. What about option D?
Uncountable.
Why? Why this is uncountable? This is uncountable. But why it is uncountable? Can anyone comment on this?
Sir, if we choose for one, if we choose 1 as image, then for 2 we can choose 2, and for other natural numbers it is free to choose. We are free to choose between 1 and 2, so we will get the same 2 to the power cardinality of n.
Right.
To the power cardinality of n minus 2, and if we choose f of 1 as 2, then we have to choose f of 2 as 2, and for other natural numbers it is free to choose.
Yes, yes, very nice, very good. So is this clear to everyone? Why
Yes,
this is
sir.
uncountable? Okay. So from my side, like if no one is saying anything, then I am assuming that you understood the solution.
Can you
Yes, sir.
explain
It's
D
clear.
part again?
Yes. Sorry, Nishita, what you said?
Can you explain D part again?
Why option D? Okay. So the option D, it is clear that f from n to 1 comma 2, the set of all functions. So the cardinality of this is cardinality of 2 raised to the power cardinality of n. So now we are given extra condition like f of 1 is less than f of 2. So here this is 1, 2, and then there are the rest elements. So one can go to either 1 or one can go to either 2. So these are two possibilities. And the other possibility for 2 is 2 can go to either 1 or 2 can go to either 2. So if we will remove this option, when 1 will go to 2 and 2 goes to 1. Similarly, there is other possibility. So how many possibilities we are moving from uncountable set? Only 2 possibilities. No, I think there is only one possibility, like 1 will go to 2 and 2 will go to 1. The other possibilities will work. So from uncountable set, we are removing only one possibility. So removing a singleton set from an uncountable set will make again the set uncountable. So is that clear now?
Yes, sir.
Fine. Okay, so let's go to the question number 9. So the question number 9 says that which of the following subset of R square are uncountable? So the first set is the pair A comma B belongs to R square such that A is less than equals to B. Second option is when A plus B is a rational number. Third option is AB is the product of two numbers A comma B. It will be an integer. And the option D is A comma B is rational number. Yes. It is clear that the option number D is
Countable. D is countable.
D is countable. So option D is incorrect. Because Q is countable. Q cross Q. It is a product of two countable sets. Is that clear?
Yes, sir.
Yes, sir.
Yes. What about option number C?
Uncountable, sir.
Uncountable. Uncountable.
Why? Why it is
So
uncountable?
because root 7 into root 7,
Right.
Is
So
integer.
take any irrational number a comma b, then multiply it. So take b to be some irrational number. Sorry, some integer into some irrational number. What about option number B?
It is also uncountable because if we take minus of
True.
√2 and √2.
Fine. What about option A?
Uncountable.
Right. So is this question number 9 clear?
Yes, sir.
Okay. So let's go to the question number 10 now. So the question number 10 says that if S is an infinite set, then which of the following statements are true? So the option A is if there is an injection from S to N, then S is countable. And option B says that if there is a surjection from S to N, then S is countable. Then we reverse the domain and codomain. If there is an injection from N to S, then S is countable. And the option D is if there is a surjection from N to S, then S is countable. Yes. Option A.
True.
True, sir.
Why?
because n is countable.
Sir,
Why?
false.
Why false?
So because injection will be there, then each element will map to the single element in the codomain.
Very good. Because we
So
are given that there is an injection from S to N. So that means
Yes.
that the cardinality of S is less than cardinality of N.
And yes, the subset of countable is countable.
Yes. What about option B?
False.
false.
Why? Can you give me counter example for that?
R to n.
Yes.
Takes
Hard to find. Yes.
What about option C? What about
false.
option C?
False.
Why?
So because we don't know
Why?
that elements will left in S or not.
Yes, the same reasoning. Take S to be R.
Yes, sir.
Then the map from N to R.
It's not countable.
Take every N goes to N. So this is a map
Hmm.
which is an injection map, but S is uncountable. What about option D?
Correct.
True.
Why?
Because subjection is there, every element of codomain will have
Yes,
a
again that
pre-image.
implies that cardinality of S is less than or equals to cardinality of N.
And 2, 1, 2 sets countable.
So is this clear? Question number 10.
Yes, sir, clear.
Yes, sir.
Okay. So let's go to the question number 11 now. So this is a question like you have to find limit of n tends to infinity 2 raised to the power n plus 1 plus 3 raised to the power n plus 1 divided by 2 raised to the power n plus 3 raised to the power n. So this is a jam question. I don't know in which year it came. So I thought like I should
2
give
by
this.
3.
Let's
But
answer it 3.
yes,
2 upon 3.
2
I
upon
think it's
3.
answer.
So one answer came is 2 by 3.
I think it is 3 only.
Other option come is 3. Why?
Oh yes, sir.
If
3
you
is the
divide
answer.
3 power n to numerator and denominator part,
How you will do it?
divide 3 to upper n to upper and lower part.
Yes. So 3 raised to the power n plus 1 we are taking out from first part, and from second part also we are taking 3 raised to the power n. So it will cancel, it will come 3 only. And this is a geometric series. Similarly down part also.
Yes, sir.
So it will go to 0 when n tending to
Infinity.
infinity. So the limit will come out to be
0.
3. Okay, so let's go to the question number 12. So this question comes in JAM 2014. So the question says that if we are given a sequence Sxn, which is 2 raised to the power 2n into 1 minus cos 1 by 2 raised to the power n for all n is in n. Then what about the sequence Xn? It will not converge, it will converges to 0, it converges to 1 by 2, or it converges to 1 by 2.
It is converges, but we have to check limit.
Why it is converges?
Because if we convert 1 minus cos theta equal to 2 cos square theta by 2.
No, that is not correct. That will be 2 sin square theta by 2.
Converts to 0.
Okay, so one answer comes out to be it will converge to 0. So this is one answer. See, in this question we are given whether it won't converge or it converges to some point. So here the question will change is just to find the limit of the sequence Xn. If it will go to infinity, then it will not diverge. Yes. So what will be the limit of this? So one hint is already given by Mahesh, that 1 minus cos divided by 1 raised to the power 2n. So this is equals to
E answer true.
yes.
D true.
Option number D.
Yes, sir.
No.
Sir, option C.
Option C. Why?
Sir, if we
Yes, sir. C.
you calculate this part like you are doing, then we will get 2 to the power 2n into 2 to the power 2n plus 2 to the power 2n plus 1 into sine square 1 by 2 to the power n plus 1. Then
Yes, sir. N plus 1 to the n plus 1.
So you need n plus 1 here, then you will
Yes, sir.
multiply by 2 square.
4. Then
we
C
will
true.
have
Yes, sir.
Then it will go to 1 by 2. Very good.
So if we expand the series also we can find.
Yes, by expansion we can do it. This is also another way. Very nice observation. Okay. So let's go to the question number 13. So this is a nice question, this question number 13. So the question number 13 says that which of the following does not ensure the convergence of a real sequence? So whenever question will come, then make sure that what we have to prove. So here the question about which does not ensure about the convergence of a real sequence. So many of the students will make a mistake like it will convert, it is true statement or it is a not true statement. So the options are summation, modulus of an minus an plus 1 tending to 0 as n tends to infinity. Then the second is about this series. The summation of an minus an plus 1 is convergent. Third is summation n into an is convergent. And the option D is the sequences a2n, a2n plus 1 and a3n. These are convergent. Yes.
I think ABC are true.
A, B, C. Okay. So one
Because
answer comes is A, B, C. This is incorrect.
in first option, if we take an is equal to square root of n,
An is
square root of n,
okay.
then an minus an plus 1, if we rationalize it, then it goes to 0, but is not convergent. After rationalize it,
Yeah, it will go to 0. It will be 1
but it
divided
is not
by 1 into 1 plus 1. So option A is incorrect. What about option B, C, and D?
So there is small doubt. The question asking is not sure about convergence.
Yes.
So then option A
So
is true.
Okay.
then option A is true.
Nice. That's why in starting I said that you have to check does not ensure. So keep in mind like what you are proving.
some case,
we
suppose
will see like which options are true at the end.
okay, sir.
So let's see like whether these statements are true or not. So you have seen that in general, this is not a true statement, that modulus of an minus an plus 1 tending to 0.
Sir, option B is the statement B is also not true, because if this series is convergent, then limit of the term will goes to 0 and it will become same as option A. So it is not true.
Okay. What about option C?
If we take an is equal to 1 by n square,
An is equals to
1 by n square, then it is divergent, but sequence an is convergent.
okay. Yes. Option D.
We cannot take like that, no sir. Option for option C.
Sorry.
So an equal to 1 by n square means n into an is not convergent, no sir. Serious.
Summation is divergent.
Sir,
So
we have
it is
to
given,
say-
it is
See, I will come to this question like A, B, C, D part again. So I'm just considering like what you are saying it. So I want from others to contradict whatever other people are saying. So that will be the
Sir,
part of the discussion.
Sir, we are using that if this option is true, then if this statement is true, then we are considering that if does the sequence n converge or not. But
Exactly. If you are disproving the statement, then you cannot say anything. So you are considering all those sequences. For example, in this part C, you are considering all the sequences an such that summation this converges. Then what can you comment about the sequence an? So this is the question. So if you are disproving the statement, then you cannot say anything about the sequence an. So this is a given statement to you. After that, you have to claim about the sequence an. So this is the question.
Okay.
Is the question clear to everyone?
yes, sir.
Yes, sir.
Yes, sir.
Nice. So that's why I said that this is somehow a nice question. So now think again.
sir, if the series n into n is convergent, then
Yes.
we can say that limit n tends to infinity n is 0. So
Yeah, this will tend to 0.
So for some epsilon greater than 0, you can find a case as that it's less than epsilon. So mod of n is less than epsilon by n.
Yes.
So n converges to 0. We can say that n is convergent.
This is what you said.
Yes.
So is there any issue in this argument?
No, sir. I think C is convergent for every n.
So C option says that if C is true, then an converges to 0.
Yes, sir.
Fine. So we have to say that which of the following does not ensure the convergence of a real sequence an. But C ensures it that if this is convergent, then an converges to 0. So C is false. But option A is correct. The same example will work. Here an minus an plus 1 tending to 0, but an is not convergent. What about option B and D? Okay, let's go to the option number D. D is easy to prove.
Sir, option D is false.
False. False, like the option is incorrect or correct?
Sorry. It is incorrect.
Okay, so you are saying that D is incorrect.
Yes.
Why?
Because
So this is
that
incorrect.
is
This is
even
incorrect. Yes, yes.
even in the sequence, even terms converges and odd terms converges.
Yes.
Therefore, an will also converge.
No, no. Your argument is incomplete. Like, see that A's 3n is also given to us. It will play some role here. So we are given that A2n and A2n plus 1 converges, but that does not say that an they will converge to limit L1 comma L2. This does not
Yes,
imply
okay,
that L1 is same as L2.
okay, sir.
So if you want to show that an is convergent, then you need to show that limits are also same.
Okay.
Yes, option D. I am saying that if these all are convergent, this an is also convergent. So this I want to prove it. So that means now I want to prove that wherever this A2n converges, A2n plus 1 converges, A3n converges, then they will converge to the same limit point, say L. So now how you will prove that the limit of all the sequences are same? Yes.
Sir, we can consider that A2n converges to L1 and
Yes.
A2n plus 1 converges to L2.
Yes.
Then for A3n, we find that the odd subsequence will converge to L1, but the even subsequence will converge to L2. But it is not true. So L1 is equal to L2.
Okay. So this is like somewhere near, but this is not the exact proof. So my suggestion, my hint from my side is like, if a sequence is convergent, then every subsequence will also converge to the same limit L. So this is my hint. Now can you give me the exact solution? Yeah, so Shashank Joshi has commented like if A2n converges and A3n then the subsequences of this A2n and A3n is A6 of n. Then they will converge to the same limit point. Exactly. So I'm saying, he is also saying like A2n has a subsequence A6n. This will also converge to L1. Similarly, this is a subsequence of A3n. So this will also converge to L3. So this implies L1 is equals to L3. Similarly, we will take a sequence of A2n plus 1, which will converge to L2, and we will take a subsequence of A3n, which will converge to L3. So the subsequences of these are same. Then this implies that L2 is also equals to L3. Let me tell you again what I am saying. Consider a subsequence A6n. This is a subsequence of A2n comma A of 3n. So it will converge to L1 and L3. Since the sequences are convergent, this implies L1 is equals to L3. Then take another sequence A6n minus 1 and A2n plus 1. Yes. So this will converge to L3, this will converge to L2. But the sequences are convergent, this implies L2 is equals to L3. So this implies L1 is equals to L2 is equals to L3. So now tell me whether this part is clear or not.
Yes, actually.
Yes, sir.
Okay. So now the only part remaining is B part. How you will do this B part? So this is a given statement. So this is a easy statement. So this also makes sure that if this is convergent, then AN is also convergent. So think this part. So the correct option is A part. So this option number B. I'm not doing it now. So do this as an exercise. Or if we have the time, then we will discuss this part B.
Sir,
Yes.
sir, can we relate option B with option A? Like for option, if option this is given statement, then limit mod of an minus an plus 1 goes to 0.
Okay.
But we have already shown that option. We have already shown that option A. For option A, it is not true. So from there, can we conclude?
In that case, P is equal to half. So that option is not work because root n 1 by n per P less than half 1, not convergent. So I think B statement is not correct for options.
Yes. So what does this statement says? What are you saying, Mahesh?
In that case, if we work with example n is root n, then after rationalizing, it becomes 1 by root n summation, which is divergent. So in that case, we can't take example root n.
Yes.
So I think in every case it is convergent.
So I'm just keeping this part as it is. So we will do it. So this is not much difficult. And the statement applies that this AN is also convergent. So I want to make sure that I will try to do many of the questions. So if the time is remaining, then we will come back to this part B also.
Okay, sir.
Yes. But this will make sure that the sequence AN is convergent. Why it will be convergent? Try to prove it. So the only option A is correct in this part. Okay, so let's go to the question number 14. So the question number 14 is xn is 1 minus 1 by 3 square, 1 minus 1 by 6 square, and so on, 1 minus 1 divided by n into n plus 1 by 2 ka whole square. Here n is greater than or equals to 2. So we have to find the limit of this xn. So these type of questions are very familiar in coming in either GATE, JAM or CSIR also. So these are example of telescoping series.
Yes, sir.
So someone comments that the answer is 1 by 9. Yes. How you will do it?
Just break last part into factor form, just like n square plus n minus 2 upon n into n plus 1 ka whole square.
Okay.
And we have to see at least 3 term. Just cut or not.
Okay. Like what about others?
So we can write it as product of 1 minus 1 by product from n is equal to 2 to infinity, or like that.
Yes, you are saying like we will write xn. Sorry.
Yes, sir.
We will write xn as product of n is equals to 2, not n is equals to 2. Say this is k is equals to 2 to n, then 1 minus 1 divided by k into k plus 1 by 2. Then how you will solve it?
Take LCM.
Okay, let's take the LCM. K into k plus 1 divided by 2 minus 1. So then
Sir, screen is not visible.
screen is not visible.
Yes, sir,
No,
not
sir.
visible.
Okay, wait a minute. Let me check why it is not visible. From my side, I don't think so. There is some issue. Okay. Share screen, start broadcast. Now screen is visible.
Yes, sir.
Okay. Yes, after that, how you will do it?
Simplify, sir.
Okay. Tell me how to do it.
We can write it as K square plus K minus 2 by K into K plus 1.
K square plus K minus
2
2
divided by K into K plus
into
1.
plus 1. Now we have to
whole.
split the numerator.
Yes,
It is
will
not
be
by 2.
Only K into K plus 1. Now by 2.
but it will come. Okay, 2 won't come.
Yes.
Okay.
Then we can split it as K minus 1 into K plus 2 by K plus 1.
So this is K
Yes.
minus
1 into K plus 2 by K into K plus 1.
Is that correct?
Yes, sir.
Now we can make it product of two different sequences as K minus 1 by K and K plus 2 by K plus 1. And when we expand, so many terms will cancel out.
Yes, sir. Right.
Yes. So this is one way of doing it. So after solving this, you will get the limit is 1 by 9. Other way is like for x, you will substitute n is equals to 2, n is equals to 3, and n is equals to 4. Then you will see a pattern. So the pattern will come out to be the same pattern. Okay, so very good. So the question number 14, I hope this is clear to everyone. So let's go to the question 15. So this question comes in JAM 2017. So here it is given that if A1 and B1 are two real numbers and a relation between A1 and B1 is given by this, 0 is less than A1 is less than B1. And for n greater than equals to 1, we define an plus 1, which is under root of an into bn, and bn plus 1 is an plus bn by 2. So the question is, which of the following statement is again not true? So the option A is both an, bn converges, but the limits are not equal. And the option B is both an and bn converge and the limits are equal. Option C is bn is a decreasing sequence, and option D is an is a increasing sequence. So this is a easy question, and the hint of this question is you can use arithmetic mean is greater than geometric mean. Yes. How we will do this question? See, we are given an plus 1 is root of an into bn, and bn plus 1 is an plus bn by 2. So this is given to us. We have to comment about an and bn.
Bn is always greater than equal to an.
Yes, so the one thing is like bn is always greater than an.
And b1.
Okay, note that this is like kind of arithmetic mean and this is kind of some geometric mean. Then you can you see like A1 is less than A2 is less than A3 and so on. Can you see this?
How, sir? Please explain.
Okay, An is this clear? Like An is always less than Bn.
Yes, sir.
So that means A2 is less than B2.
Yes,
And
sir.
also we are give. Okay, just wait a minute. A1 is less than B1. This is given to us.
Yes, sir.
So this implies A2 is less than B2.
Okay.
And
Yes, sir.
A1 is less than A2. Reason is An plus 1. So for n is equals to 1, A2 is root of A1
Sir.
into B1.
Yes, sir. Right. Yeah, I can tell you. Yes.
So with similar argument, A2 is less than A3. So we will get A1 is an increasing sequence. So is this statement clear? This statement?
Yes. Yes, sir.
Yes.
Everyone, is this clear to you?
Yes. Sir.
Yes, sir.
Okay. So similarly, we can claim that B1 is greater than B2 is greater than this. This Bn is a decreasing sequence. Can you claim this statement?
Yes, sir.
So this means that you have shown that Bn is a decreasing sequence. So this is incorrect because in the question we asked the following statements are not true. Similarly, D is also false. Now we have to show that both An and Bn converge, but the limits are not equal. Both An and Bn converge and the limits are equal. So the options are saying like An and Bn both will converge. Okay, so now note that we have shown that An is an increasing sequence and Bn is a decreasing sequence.
Yes.
ठीक है? So if you know the result by Bolzano-Weierstrass theorem that every monotonic bounded sequence is convergent.
Yes, sir.
Then from that An and Bn are convergent sequences.
Right, sir.
So my question is why An and Bn are bounded?
All terms in A are bounded by B1.
Sorry?
So the sequence An is bounded by Bi's and the sequence
Right.
Bi's are bounded below by A's.
Right. So we have this. Basically, just wait a minute. So we have this that A1 is less than A2 is less than zone An. This is less than Bn minus 1, so on, less than B2, less than B1. So this Bn is bounded below by A1 and this A1, this is bounded above by this Bi's.
VM.
Yes, so this An and Bn are converging sequences. So now what is the left to prove is that limits are equal or unequal. How we will do it this? Yes. Say Bn plus Bn will converge to L1, An will converge to L2. Then from this will left hand side will converge to L1. Right hand side will converge to L1 plus L2 by 2.
Yes, sir.
Then
It
this
means
implies that L1 is equals to L2.
yes, sir.
So this implies that option B is also incorrect. Because the question asks about which statements are not true. So these types of questions will come like the question asks about true or not true. So make sure that you will correct a correct option. Okay, sir. So let's go to the question number 16. So the question number 16 asks about limit n tends to infinity 1 divided by root n plus this summation. Yes, how you will do this? Any idea?
Yes, sir. Take any term and rationalize it.
So rationalizing each term.
Hmm.
Fine.
Yes.
So that the denominator difference becomes same.
So am I doing correct or incorrect? Tell me.
Correct, sir.
I have
Correct,
rationalized
sir.
root 3 minus root 3n minus root 3n plus 3. So downstairs it will come as a formula of root of a square minus b square.
Yes, yes, sir.
So from here that minus 1 by 3 will come common from all the denominators. So this is root 3 minus root 6 plus root 6 minus root 9 plus so on.
Sir, it will be root 3n
Yes,
minus
sir.
root 3n plus 1.
Thank you for correcting me. So is that correct now?
Yes, sir.
Yes.
So these whole terms will cancel out. Then this will minus will make this positive. Minus minus will also cancel out. Then this take the limit of this function. Limit n tend to infinity. 1 by 3 will come out common. Root 3n plus 3 divided by root n. So this is root 3 by 3. So the answer is 1 by root 3. Okay, so let's go to the question number 17.
Sir,
Yes.
say it's root 3 plus 3 plus root 3 isn't, should it be like this?
So this will same as root 3n plus 3 divided by n.
Yes, sir. And plus root 3 by.
Yes, and this is same as root 3 plus 3 by n. So this will go to 0.
Yes. Okay.
Yeah. Okay, so let's see this question number 17 now. So the question number 70 says that if n is a sequence of real numbers such that a1 is 1 and n plus 1 is given by this formula. Then you have to comment about what is A4, limit of this, and this. So this one is easy to prove that. Simply by putting n is equals to 3 in this, then find the A3. A3 is same as A2 into A2 plus 1. Then what is A2? A2 is same as A1 into 1 plus A2. So substitute these values of A2 and A3 in this, you will see that option A is correct. So now my question is how you will do question number 17 part B and C. And what about part D? Is the limit of n tending to 0? This is clearly visible.
Sir, in question an plus 1 equal to an plus an square only.
Yes, take n to be common in that. Then it will be n into n plus 1. Isn't it?
E is not true because it is tends to infinity.
So an is an increasing sequence.
Yes, and A1 is 1. So this will go to infinity. So this is incorrect.
B is true.
Why? Why B is true?
N tends to infinity, then 1 by n tends to 0.
Right. But how you will claim that n tends to infinity?
Because increasing sequence unbounded above.
Can you give me the proof of this, like n tending to infinity? It is the same as 1 by n tending to 0. Yes. Anyone?
Ans are greater than or equal to n.
Sorry?
An greater than or equal to n.
An is greater than or equals to n. How?
So n tends to infinity. So for any positive number n, we can find a case such that ak is greater than m. So,
Okay, so
1 by
So A1 is 1 here, then A2 is what? 2. So directly from here also we can say like. Okay, directly it will go that n tends to infinity. Okay, so there is no question in that. I have done it in another way, this question. Anyway, let's go to the question number 18. I hope that question number 17 is clear. So the question number 18 is similar to that of the previous question we have done. What is the limit of this? So this is same as telescoping series. So the answer will come out to be 1/4. So this question I will left it as an exercise. So the same technique we will do it. We will open this KQ minus 3 as KQ minus K as K minus 1 into K plus 1. Then in numerator we will write it is as the difference of these terms K plus 1 minus K minus 1 and divided by 1/2. So this is a hint of this question. Okay, so let's go to the question number 19. So this is a nice question. So what will be the limit of this? How you will do this question number 19? What will be the limit of this? 8 and minus 1? 1. Okay, so the one answer is 1. What about others? How you will do it?
So we will divide it into two parts, like 8n minus 1 by n to the power 1 by n square.
Yes.
Where n is some even number.
One by n square when n is even. And then?
8 power minus 1 by n square when n is odd.
Okay. Then? Assume
Then if
this,
we
yeah, assume this is L, then take the log on both sides. Then find the limit of this. After solving this, you will get the limit of this is 0. So this implies that L will tends to. So is there any other way of doing this? Yes, no.
Sir, can we do like means 8n minus 1 upon n raised to minus 1 raised to n upon n square, and in the power we have minus 1 raised to n upon n square, and we directly put n square is equals to means tends to infinity, so whole power will be 0 and anything to the power 0 is 1.
Sorry, how you will do it? Can you explain again?
Sir, I said we have given the power minus 1 raised to n upon n square.
Right.
And if we directly put n square means in the power term, n square tends to infinity, so whole power becomes 0 because anything raised to anything upon infinity becomes 0. So, and anything raised to power 0 is 1. So, means I'm
Okay,
asking, can
so
we do like this?
I don't think so. Like we will do it. So let's put this question to others also. So she is saying that say this function is f of n and here it is g of n. So this function gn is converges 0. So this will go to 1, any raised to the power 0 is 1. So is the correct way of doing it. So is this what you were saying?
Yes, sir.
Yes. So is this the correct way of doing it?
The limit
Always
should
if we
exist
take
finitely.
fn equals to 1 by n.
Sorry?
If we take fn equals to 1 by n, then 0 to the power 0.
Okay, fn is 1 by n ki power 1 by n.
Sir, I think the limit of fn should exist finitely.
Okay. Anyway, the limit
Not
of
equal to.
this is 1. So this is same as 1 divided by n raised to the power 1 by n, and n raised to the power 1 by n goes to 1. If I am correct. But anyway, this is not correct way of doing it.
Okay.
Yes. For example, you can take n square raised to the power 1 by n. I hope so. This 1 plus, take n square plus 1 raised to the power 1 by n. I hope so this example will work. This won't go to 1.
Sir, n factorial power 1 by n.
Oh. Sorry?
N factorial raised to 1 by n.
N factorial raised to the power 1 by n. Where it will go?
Diverges.
It diverges. It goes to infinity. So this is not a correct way of doing it. So there are many counterexamples. So you will see that for some functions, like this is one function, it will go to infinity. Anyway, we don't have that much time, so let's go to the question number 20. So this question, this is also a nice question, an easy one. So the question says that if px is a polynomial in the real variable x of degree 5, then what will be the limit of this? So here Pn stands for, if say we have a function f of x which is x square plus 1, then f of n means n square plus 1. So here p of x is a polynomial in variable x of degree 5. So this is the meaning of p of n. We will substitute n in the place of x. So then what can you comment about this limit of Pn divided by 2 raised to the power n?
0.
Yes, it will go to 0. So the answer of this is that x raised to the power k is less than, for any k, or I must say for any fixed k, x raised to the power k is less than 2 raised to the power x for large x. So whenever this n tends to infinity, the ratio x raised to the power k divided by 2 raised to the power x, this will go to 0. Okay, so let's go to the question number 21. So the question number 21 now is about the limit superior of n and limit inferior of n. So again, do it for when n is even and n is odd. Can you tell me the limit set of this sequence n?
1 minus 1 by n to the power n and 1 plus 1 by n to the power n.
So for when n is even, then the sequence a of 2n is
1 plus 1 by n to the power.
1 plus 1 by 2n raised to the power 2n. And when n is odd, it is a 2n minus 1 is 1 minus.
Option D is correct.
So it will go to E and it will go to 1 by E. So option D is correct. So is this clear why option D is correct?
Sir, why it's going to E?
This A of 2n?
Yes, sir.
So this is a subsequence of this function. That 1 plus 1 by n raised to the power n. You know that this will go to E?
Yes, sir. Yes, sir. Yes, I got it.
Yeah, we are taking a subsequence of this.
Yes.
Okay, so let's go to the question number 22. So this is the last question I have. So in this question number 21, we have x1 is 0, x2 is 1, and for n greater than equals to 3, we define xn in this way. So the question is about xn is a monotone sequence, limit n tends to infinity, xn is 1 by 2, xn is a Cauchy sequence, and limit n tends to infinity, xn is 2 by 3. Yes, how we will do it? So xn is xn minus 1 plus xn minus 2 by 2. How we will do it? Can anyone tell me? Any idea?
Sir, it's an AP.
It's an AP, sure. X2 is 1. Okay, so what is our x3? X3 is
1 by 2.
0 plus 1 by 2, which is 1 by 2. What is x4? 1 plus 1 by 2 divided by 2, which is
3 by 4.
3 by 4. What is x5? 1 by 2 plus 3 by 4 divided by 2, which is same as 5 by 8. Right or not?
Yes.
So x1 is less than x2 and x3 is less than x2. X1 is here. Then for x4 is x1 less than x3 less than x4 less than x2. Then x5 is where x1 is less than x3 is less than x5 is less than x4 is less than x2. So it is not an AP for sure. So this is not an AP, like we will prove it why it is not an AP, but this gives us a hint like this is not an AP.
Yes, sir.
So now can you comment on anything, how we will proceed? Any idea, any intuition? So by putting the values of n is equals to 3, 4, 5, This gives us a hint that xn is not a monotonic sequence.
Yes, sir.
So the pattern, if you will check it, the pattern will go like that: x1 less than x3 less than x5, then x7, x9, so on. Where here is some like x6, x4, x2. Yes, how we will prove it? Okay, so for Cauchy, what we have to show?
Mod of xn minus 1 is less than epsilon.
So this is one way of doing it, like the difference of two consecutive numbers of a sequence are less than epsilon. So the general statement is this, that xn minus xm is less than epsilon. Whenever this n comma m is greater than equals to n naught. Okay, so let's find it. What is this xn minus 1? What is this? So it is xn is what? Xn minus 1 plus xn minus 2 divided by 2 minus xn minus 1. So this is same as xn minus 2 divided by 2 minus of xn minus 1 divided by 2. Is that clear?
Yes, sir.
Similarly, we can find this xn minus 1 minus of xn minus 2. It will comes out to be xn minus 3 divided by 2 minus of xn, sorry, xn minus 4 minus of xn minus 3 divided by 2. Sorry. It will come xn minus 2, 3, xn minus 3 divided by 2 minus of xn minus 2 divided by 2. So can you see a pattern here?
And mod of xn minus 1 is less than 1 by 2 to the power n.
Yes. Okay, so what will be my x3 minus x2? Tell me whether this is correct or not.
Yes, it's correct.
Yes. Now can you tell me how we will do it? Okay, so let me give you the answer of this, then tell me how you will do it. The option C is correct and option D is correct. So the limit will come out to be 2 by 3 and xn is a Cauchy sequence. Just tell me how we will do it.
If we take 2 to the left side, that is 2 of xn is equal to xn minus 1 plus xn minus 2.
Yes, 2 of xn is xn minus 1 plus xn minus 2.
And if we divide throughout by xn,
If we will take, so you are saying that 2 of xn is same as xn minus 1 plus xn minus 2.
yes, sir.
Then,
So if we divide each of it by xn, that is 2 is equal to xn minus 1 upon xn plus xn minus 2 upon xn.
okay. Then,
No, sir, it's not working.
yes. So is there any other way of doing it? Yes. So Shashank has commented just put value of n, we remain to some points. Yes, tell me how we will do it. Okay, just add these terms. Can you get anything from that? So these all terms will cancel out. This will cancel out. So what we will have it? We will have it this xn, this all will cancel out. We will have xn minus x2 is same as, on the right hand side we will have minus of xn minus 1 divided by 2 plus this will cancel, this will cancel. So at the end, what we will have? Is this correct or not? Tell me.
Yes, sir.
Yes, sir.
What is our x1? X1 is 0. And x2 is 1. So whenever n tends to infinity, xn comma xn minus 1 both will converge to the same limit quantile. So what we have? L minus 1 divided by minus L divided by 2. L plus L by 2 is equals to 1. So this implies L is 2 by 3. So option D is correct. So the only thing that remains is xn is a Cauchy sequence. So let me give you a hint, then do it by your own. Let's see these sequences. X1, X3, X5. These all are the odd sequences. So this is bounded above by X2. Similarly, this X2, X4 and this similarly X6. These are monotonic decreasing sequences. And this is bounded below by X1. So every subsequences which are monotonic and bounded, and they are converging to the same limit point. So these are convergent sequences. So if a sequence is Cauchy, if and only if it is convergent. Can you see this? How this is a Cauchy sequence? Yes, no, anything?
Yes, sir.
Okay, nice. So For question number 22, option C and D is correct and option B is false. So this is it from my side. If you want to ask any question, you can ask.
Hey, thank you, Himanshu, for this nice session with a good collection of previous year problems. Dear participants, now it is your time. You can ask any doubts or you can share any comments regarding the lecture.
Good evening, sir. I am
Yeah.
Gauri from St. Teresa's College, Ernakulam. Sir, it was really a great experience and informative session. Especially, I would like to point out the way you interacted with us and made sure that each and every question is clear to us. And I would like to thank you, sir, for sharing your valuable time and knowledge with us. And especially, I would like to convey my heartfelt gratitude to Vinod, sir, for organizing such great classes and giving us exposure to many great persons. It was a really great day for us, sir. Thank you so much.
Hello, sir. My name's Alina Anna Matthews. I'm currently a third year B.Sc student of Marthoma College, Chungatra. Thank you, sir, for your wonderful class. You explained each and every question so thoroughly, making us understand it. Even when we asked doubt, you repeated it. Thank you, sir. Thank you, Vinod, sir, for organizing such a class.
I am Dia. I am from M.Sc second year. I am studying my M.Sc in IIT Bhubaneswar, and so this class is very helpful for me. And the discussion you held while solving the problems, it is very beneficial to me. Thank you, sir, for organizing this class. Thank you.
I'm Nishita Pendharkar. I'm TYBSc Mathematics student from Maharashtra. So today's session was really very nice. The problems you had selected for us and your technique, your style of explaining each and every problem was just amazing. I'm very thankful to you, and also I'm thankful to Vinod sir for making you available for us, and thank you so much.
Today's session is really nice. You explained each and every question really well. You discussed so many previous year programs, and it will really help for our preparation. Thank you so much, sir, for your time and effort. And thank you so much, Vinod, sir, for conducting this session for us.
Thank you, Gopika.
Hello, sir. I'm
Yeah.
Ms. Khan, and I'm just completed with my master's program. I've completed my MSc from Allahabad University. So, sir, I just wanted to ask you a quick question about your PhD. Sir, I'm thinking about enrolling in PhD, and I'm preparing for exams currently. So, I just wanted you to share some insights about your PhD program. I think you are doing it from IIT Delhi. So can you, sir, share your experiences with us? It would be great help.
No, actually, here the experience is very good. There are a lot of things that we need to do it. So even for PhD also, we need to enroll and we need to do some coursework also. So after that, we need to give some exam. We need to give some comprehensive exam or oral exam. After that, we will be a part of the PhD program. Before that, we are just the enrollment students, like we are not the full students of a PhD.
Okay.
So this is in every institute or maybe in every other universities. I don't know about that. But for IITs, like you need to give these two exams.
So you're saying that after even enrolling in such institute, after your gate, you give your gate and interviews and all that. This also doesn't ensure that you are in a PhD full-time PhD program.
Yes. Actually, they make sure that you understand everything so that you can do the research properly.
Okay, sir.
So before making them you a full student, they want to make sure that yes, now
Okay, sir.
you are a full-time PhD student. You can do
So
the research.
are you doing your coursework right now?
No, I'm not doing a coursework right now. Like for first year only, we have to do that, and after that, it is your choice. Like if you want to learn anything new, then you can do that. But
Okay,
for
तो
first
सर मतलब आप enroll हो चुके हैं maybe और enroll मतलब for full time
no,
PhD.
I am enrolled now. I'm in the 4th year of my PhD now.
Okay, sir. That's very
Yeah.
nice. Sir. That's so great talking to you and have an interactive session. Sir, can I know your what field you are doing your research in?
I'm working on commutative algebra.
Commutative algebra. Okay, sir.
Yes.
Pure and okay. Okay. Thank you, sir. Thank you.
This is Tejashwini here from Karnataka. It was an amazing session, sir. Everything is in crystal clear. Thanks to Himanshu sir and thanks to Vinod sir for conducting such an amazing sessions for us.
Hello, good evening, sir. I'm Shikha. I'm a second year M.Sc student. Currently, I'm doing my M.Sc from Birla Institute of Technology, Meshra, from Jharkhand. And sir, your session was really nice. Actually, I always used to face some difficulty in real analysis, but your questions and your explanation gave some insights to how to approach these questions and all. So I will try to learn more and more concept about it. So it was really nice. And thank you, Vinod, sir, for conducting such sessions.
Thank you. Thank you, Shikha.
Hello, sir. My name is Aparna Lal. I'm from Kerala. So today's class was very nice. Actually, I'm a bit backward when it comes to reanalysis. For me, the conceptual part is very hard. But today, when I was through your class, I just know that it became easy and how to approach all these questions. So thank you so much, sir, for sparing your time with this. And also, Vinod, sir, thank you so much for conducting this session. Thank you so much, sir.
Thank you, Aparna. Okay, any others? If any of
Hello,
you...
sir.
Yeah, yes.
Hello, sir. I'm Malavika, third year B.Sc Maths student of 𝕸𝕤𝕤𝕤 Gurarapan College, Kerala. Thank you, sir. Thank you so much, sir, for this session. We clearly understood the questions you were discussed today. And thank you so much, sir, for sharing your valuable time with us. Also, I would like to thank Vinod, sir, for conducting such a wonderful session for us.
Thank you, Malavika.
Hello, sir.
Yeah.
I'm Bhavani. Thanks for this session. It's really helpful for us realize a difficult subject for all of us. Also, I'm a mathematics student. I'm currently in third year of B.Sc. And thank you, Vinod sir, for this session. Thanks.
Bhavani, could you introduce yourself? From which college you are?
I'm from University of Calcutta, Bhavanipur Institute.
Okay, West Bengal.
Yes.
Yeah, thank you. Thank you, Bhavani. Okay, any others? Yeah,
Hello,
Sakshi.
sir. My
Yeah.
name is Sakshi and I'm currently pursuing my master's from Delhi University. And your session was very useful as you cleared each and every concept from the basic. So I enjoyed a lot in your session and thank you, Vinod sir, for conducting this useful session.
Yeah, thank you, Sakshi. Any others?
Sir,
Yes.
I'm Anamika from 𝕸𝕤𝕤𝕤 Gurarapan College, Kerala. Your questions were really nice, and the way you explained was really nice, sir. Thank you for the session, and thank you, Vinod sir, for this wonderful session.
Thank you, Anamika. Yes, Lakshmi.
Hello, sir. I am Lakshmi. I am from TMG College, Tirur, Kerala. Today's class was really nice, interesting, and very informative. You explained each topic very clearly, and your explanation was very easy to understand. Thank you, sir, for spending your valuable time with us, and thank you, Vinod, sir, for conducting this class. Thank you.
Thank you, Lakshmi. Okay, any others? Otherwise, we will wind up here.
Good evening, sir.
If
Myself, Shilpa. Thank you, sir, for spending your valuable time with us. You helped all of us by discussing the various questions from various competitive exams. Thank you, sir. Thank you, Vinod, sir, for organizing such a wonderful session.
From TMC College, Tirur. Today's class was very nice and interesting. And thank you, sir, for your valuable time with us. And thank you, Vinod, sir, for conducting this class. Thank you.
Yeah, Himanshu, thank you very much for being with us and wish you all success in your research and academic career. Thank you again.
Thank you so much. and it's a very nice experience for me also. Like now,
Ah.
I would like to have more sessions.
Yeah, that is needed. It is a request from my side. Please be with us in future too, and also engage these type of sessions. Yeah, today's participants are actively involved in the discussion, so I think they have enjoyed your session. So you are a very good teacher. I'm really feel that. So you will be an asset to any institute where you are joining as a teacher, as an assistant professor. Okay. Anyway, all the best. All the best for your career.
Thank you so
Thank
much.
you.
Yes,
Yeah.
sorry to interrupt. We are looking for more session from your side. Thank
Yeah,
you,
yeah.
sir.
Yeah, Babani, yes.
Thank you.
Yes. Okay, let us wind up here. Bye.